SAS demonstration macro demo 2. In this demonstration, we are going to look at how we can use macro language to communicate between SAS data steps. And again, this program was developed by Fred Ulrich, who was a computer programmer here a number of years ago at the College of Public Health. So we're going to create the same data set that we used for the SAS demonstration macro demo 1. And we're calling that data set work. And we're inputting the initials, height, weight, gender, and time that these variables were recorded for each of these observations. So again, this is just a simple data set for how we can use the macro language. So let's just print out these observations again. Look at the data. And we see here we have 68 observations on 4 different variables. In this next step, we want to calculate the mean weight for the entire data set. So we're bringing in our data set work, and we're using no print because we're not interested in seeing a printout of the mean. But we're creating an output data set called stats. And on that output data set, there's going to be a variable that has the name mean, which is going to be the mean weight for the entire data set. And so this data set stats is just going to have one observation on that data set. And then we are going to use the underscore null underscore as the data set name because we're only interested in processing records from a file, but we're not interested in creating a resulting data set. So we're going to just use this data step for processing. And basically what we're doing in this data step is we're calling the simput routine to create a macro variable called average. So we're saying data underscore null underscore, bringing in this data set that we created from proc means, which just has one observation, the mean weight for our entire data set work. And we're going to create a macro variable called average, which inserts that mean value into that macro variable. So that's all we're doing in this data step. And once we've completed this data step, we then can make use of our macro variable in either a new data step or a new procedure. So here in this procedure proc print, we're bringing back in our old data set, data equals work. We're interested in printing out the initials and the weight, and we're only interested in printing out those observations whose weight was greater than the average weight of the entire data set. And so we're making use of our macro variable here, and we don't even know what the mean weight of our entire data set is because we never saw a printout of it. So we are able to communicate between these data steps without ever looking at the output. And then notice I have a title statement with double quotes, and then I can actually have my macro variable printed in the title, the value of the macro variable, because we're using double quotes. So let's run all of this code and take a look at our proc print output. And so this is our output. We see here our title is subjects greater than the average weight, where the weight is in this form. We have a lot of values to the right of the decimal point. So these are only the subjects whose weight was greater than the average, which was about 79.96. So all of these subjects have weights greater than the average weight of the entire group. Let's say we want to look at other measures besides weight. Here we are going to create a macro variable and call it measure and use it in the proc means procedure. So first of all, we're getting a little more complicated. We're starting by defining a macro variable called measure, and we're setting it equal to weight. And then we use our macro variable in our procedure proc means. So it's similar to the code above, except that rather than having weight in our var statement, we have our macro variable in the var statement. And then once again, we are going to use our data underscore null underscore just to process this one observation with the call simput routine. And notice here that I'm creating a macro variable called average. Instead of having the average printed out with all those digits to the right of the decimal point, I'm formatting my mean with a put statement. So here we use a put statement to have the variable mean written in 7.2 format. And then we're going to print out each observation's initials, this macro variable ampersand measure, where ampersand measure is greater than the ampersand average. And so we're doing a lot of substituting with macro variables here. And again, we have our title statement with double quotes. So let's take a look at what all this looks like. So here notice we see subjects greater than average weight 79.96. And again, we have the listing of these subjects whose weight was greater than the average weight. So why did I do all this with creating this macro variable called measure? Well, let's say I was interested in doing all of this, but instead of using the measurement weight, we're going to use height. So all I need to do is change it to height. And now, when I run all of this, first of all, we're going to calculate the mean height and create an output data set called stats. Then we are going to create a macro variable average, which is going to be for the average height. And then we are going to print out all those subjects whose height was greater than the average. So all we've done is changed our variable to height or some other measurement if it was on our data set, and we could do exactly what we had done before with the variable weight. So let's run all of this now where we've changed our measurement to height instead of weight. And so here you see this is a listing of all the subjects whose height was greater than the average height for this group of subjects, which was 171.40. And we're in the metric system here for height. And so you can see here that we are given a lot more flexibility to work with our data when we make use of the call simput procedure, as well as when we make use of macro variables. Again, at no point did we have to go into our output to determine what the average height was. We were able to communicate within the data steps by using call simput. This completes the SAS demonstration, Macro Demo 2.